Hello, I'm Jennifer Keller, the Programming Coordinator at the Westport Library, with Peter Davern, author of the new poetry collection called From Arsenic to Zirconium, Poems and Surprising Facts About the Elements. In honor of National Poetry Month and the hashtag Shelter in Poetry campaign, the library is celebrating the art of the poem, and I am super excited to share this collection with you. Thank you for joining me, Peter.
Oh, you're welcome, no problem. Thanks, Jennifer. Thank you.
Peter is a chemistry lecturer at the University of Limerick, and he spent 9 years in the pharmaceutical industry before that. So he's a little different than the poets that we've been talking to. Would you share a bit about the inspiration behind From Arsenic to Zirconium, Peter?
Yeah, sure. And first of all, thanks for getting in touch as well. It's nice to be able to talk about it. Yeah, I suppose the inspiration has to do with my interest in the periodic table of the elements, but my poor memory, I guess, and that I could never really remember, many of the properties of the different elements. There's 90 odd naturally occurring elements, and then there's another nearly 30, man-made elements, and I found it difficult to remember stuff about them. So I decided to write a short poem that would incorporate maybe a handful of the properties of the different elements. And I started with hydrogen, the very first element number 1, and it was just a short little poem, and kind of took it from there. Now it took about 5 years or so all in to get them all, to work my way through them, and kind of, it turned out to be a little bit of an obsession, I guess. But yeah, it's done now, thankfully, and it's going to be coming out, which is great. Yeah.
Great. Now, would you share 1 or 2 poems from this collection? I know that I've been actually talking to a friend of mine whose daughter is home from college, and she has to write a poem for her science class. Okay. So would you give us some of your poems so that the students can be inspired as well?
Yeah, well, I'll give it a go. I'll read you the one for hydrogen, and I guess it's slightly different to the rest of them, mostly in that most of them they're all 5-liners, and I kind of was initially going with the idea of limericks. This limerick format. Was it AABBA, something like that? But it didn't pan out that way because I just couldn't get enough properties in there about the elements. So hydrogen it's short. So it's called the Rocket Man. Is the title of it for hydrogen. And it's on the table. It sits at the top. Test tube lit. It explodes with a pop. Most abundant by far. Powered rocket now car. Less its bonds watered ne'er be a drop. And DNA's double helix would flop. So that's hydrogen. Short and sweet.
I love that one.
Yeah, the idea is, I guess, that it's the element at the top of the periodic table. And any high school students will probably know, if they've done chemistry in the lab, the test that they do for hydrogen is when they make it as a gas in a test tube, you light it and it pops. Test tube lit, it explodes with a pop. And it's the most abundant element in the universe. And it's used as rocket fuel, and in the future we might be using it in cars more so, and it'll be much cleaner than fossil fuels. But it's crucial to life on Earth for 2 reasons. Insofar as, water is a tiny molecule, H2O, yeah, really, really small, really, really light in relative terms. It really should be a gas, at normal room temperature. But the hydrogen of one bonded in one water molecule is kind of mildly bonded to an oxygen in another water molecule, and that spreads throughout the whole lot, and they're called hydrogen bonds. They're kind of weak bonds, and it's the reason the water can flop around in a glass or a container. These little hydrogen bonds are making and breaking all the time, and also those hydrogen. So normally there should be no water to drink. It should all be a gas, but these weak but multiple hydrogen bonds keep water a liquid at room temperature. And in DNA, that spiral, this helix, this double helix that we have in DNA, that's held in this double helix shape because of these little hydrogen bonds. Without that, then DNA's double helix would flop. literally it would fall apart. You know, they're
Mm.
crucial to our lives on Earth, you know, water and DNA. Yeah, so
Right.
it was those sort of things that I kind of tried to pull out. You know, I had maybe 5 or 6, no, yeah, maybe 5 or 6 different key sources, and then online sources and books. And I'd read through them all, and then I'd write down, jot interesting things about the different elements. And then I cycle out to the university where I work along by the River Shannon here in Limerick, past King John's Castle and along by the canal and stuff. And I used to chew over the words and the lines in my head as I was cycling along. And then I get into the university and jot them down quickly before I forget them, this kind of thing. You know? So kind of that sort of stuff, really, you know?
Right.
Yeah.
Now, I did see, though, that sulfur has an effect on whether one has curly hair. So would you read sulfur for me? Because I'm dying to know.
Dying to know. Okay. So sulfur, sulfur then we're talking about, here's yellow S, volcano born, its compounds stink like hell. From skunk scent, bad breath, rotten eggs to garlic's taste and smell. Its acid, workhorse of our world, its bonds define hair, straight or curled. Sulfites as SO2 preserve, S spocks our tires as well. So your question about the curly hair and that, you see, hair is, it's made, it contains keratin, and that's a protein, right? And these proteins contain amino acids. And one of the amino acids of the family of amino acids is cysteine. And cysteine has sulfur atoms in it. And sometimes you can get sulfur atoms of one cysteine on one part of the hair, kind of, or a microscopic part, bonding to another cysteine in another part, and that causes the hair to curl.
Oh, how fabulous.
Chemical bonds, sulfur to sulfur bonds, you know. So if you have a lot of cysteine in your hair, in the keratin, chances are you'll get, exactly, yeah, you'll get curly hair. And if you've straight hair, then yeah, you don't. And you know, you can use, you know, perming agents, and it's a chemical reaction to perm your hair or to straighten it and all this kind of thing. The heat breaks them and making and breaking of bonds with heat, these kind of things. There's a lot going on there.
Well, I've certainly learned something today. Thank you.
No problem, no problem.
So many of us are looking for ways to entertain ourselves and family members while in isolation.
Yes.
And so my question to you, I've been asking poets, you know, how they're getting through with poetry, but since you're a chemist, is there a science experiment we can do at home based on your collection of poems?
Yes, you can, and it kind of relates to sulfur, actually. I'll show it to you here now. This might just take a little bit of setting up. I'll try now. I'll move the camera down here. Can you see the jug?
Yes, we can.
Yeah? Okay, yep. So bear with me now, and I get a little bit of aluminum foil, all right? Yeah. Or kitchen foil, whichever. And I'm just going to put a little bit of it in here. What I'm going to do is, if you have any silver jewelry, silver cutlery, you know, the tarnishes, the tarnishing apparently is silver sulfide. So it's sulfur again. It's silver sulfide is a chemical compound made of silver and sulfur bonded together, and it's a black solid. And I have here as well, maybe you can see it, I'll just put a white sheet of paper. You can see it's a cake knife, yeah? And the handle of it is made of EPNS, so electroplated nickel silver. So there's a layer of silver on it, but it's quite tarnished, it's quite black. Does it come across as kind of darkish looking?
Yes, it does.
Yeah? Okay, all right. So imagine this is your jewelry or your cutlery, and the handle here is this tarnished silver. And what you do is, I'll just get some boiling water. Bear with me. Okay. Okay, so we're good? Yeah.
Yep.
And I get some, I don't know if you can see this now, so bicarbonate of soda, baking soda for making bread and cakes, I guess. Yeah, and I just put a little bit in. Now, I just give that a little bit of a stir. Use a biro or a pen. Okay. So these are all, I guess, household chemicals, really. Aluminum, you say in the States. and bicarbonate of sodium, so sodium hydrogen carbonate or sodium bicarbonate, different names for it. And if you immerse the silver in it's very hot water, but just gone off the boil, so you want to be careful with that. If you immerse the tarnished silver in the liquid, but you must touch the aluminium, touch the aluminum, touch the foil, and you get a chemical reaction whereby the sulfur transfers from the tarnish over to the aluminum foil and restores your silver to its original state, hopefully. Let's see what happens now. Let's give it here for a second. So can you see that it's touching the foil maybe?
Yes, actually, I think I can see that it's actually changing.
Can you see it there? I'll just get the page maybe. Can you see the difference? No?
Yes, indeed. That's fabulous.
Yeah. Now, I mean, if you leave it in for longer and hotter solution and so on, you should restore your silver. It's a chemical reaction basically that sulfur, let me see if I get it the right way around. Aluminum has a greater affinity for sulfur than silver does. So when you introduce the two together in what's called an electrochemical reaction, that's what we're doing here. The sulfur transfers from the silver over to the aluminum, and you're left behind with your silver is restored, or the little bit that I immersed in the liquid, but also you have to touch the object to the aluminum. Yeah? Do you get it?
Great.
Yeah?
Yes, thank you so much, Peter.
That's okay, no problem, you're welcome.
Thank you for sharing that with the Westport Library community. Those of you at home, I hope that you will be sure to read more of Peter Davern's collection, From Arsenic to Zirconium, either by buying it through your favorite book retailer or reading it through the library's catalog. For more author videos and information about the Westport Library, remember to visit westportlibrary.org. Thank you so much, Peter.
You're welcome, Jennifer. It's great talking to you. Yeah, and best of luck over there, eh?
Thank you.
No problem.